Okay, this is a reach back for grade 8. Today's date is October 20th. Oh my God, it's October 20th. That means there's only 11 days till Halloween. And that means there's 12 days until I get a year's supply of cheesies. From all of my students who don't like cheesies, they're going to bring them into me and let me get really plump for November. The first four questions are reachbacks to grade 7. Fraction sets from grade 7, addition and subtraction of both mixed fractions and proper fractions. Our first question is pretty simple. It says a half plus 3/8. Now, some of you could probably do that in your head because you can probably make the transition in your head and say that's 7/8 because a half would be 4/8. 4/8 plus 3/8 is 7/8. But you have to first find your common denominator. And if we were to look at the common multiples of 2 and 8 halves, the multiples of 2 are 2, 4, 6, 8, 10, 12, etc. Multiples of 8 are 8, 16, 24, etc. So the first one they share is the multiple of 8. And what we call 8 is your lowest common denominator. And we could find many, infinite common denominators that we can use, but the first one they share is called the lowest. And the reason why we like to use the lowest is it makes our fractions much simpler to use. So we have 3/8 over here, and over here we have 4/8. And once we have that, the rule for adding fractions is keep your denominator and add your numerators, and your final answer will be 7/8. A lot of teachers made their students write this step out to remind them that the process is keep your denominator, add your numerators. If you're not in the habit of doing that, but you make a lot of mistakes, get into the habit of writing that. It'll help you remember what to do. In the second question, same process, except this time it's subtraction. So our multiples of 4 and 5 is 4, 8, 12, 16, 20. It's 5, 10, 15, 20. So the first one they share is the number 20, which means that will be our lowest common denominator. So I'll put 20 down here and 20 over here. Now the equivalent fraction part, which I probably should have stated in the first one, in order to create an equivalent fraction to 3/4, to an equivalent fraction that has a denominator of 20, I need to really, maybe on the margin somewhere, go, okay, 3/4 is equal to how many 20ths? And the process of creating equivalency says, if you multiply your denominator by 5 to get the new common denominator of 20, do the same multiplication to the numerator and you'll get your equivalent fraction. So the equivalent fraction to 3/4 is 15/20. And again, if you wanted to show why they're equivalent, you could actually take them both and change them both to decimals. If you grab your calculator and say, well, what is 3/4? So 3 divided by 4 as a decimal, it's decimal 75. And what is 15 divided by 20? It's also decimal 75. So it's both representing, you can think of it as being decimal 75, you can think of it as being 75% of something, but they are equivalent because they are the same number. And 1/5, since I multiplied 5 by 4 to get 20, I'm going to multiply the numerator by 4 as well to get 4/20. Once you have that, you're going to keep your denominator and subtract your numerators. And your final answer will be, 11/20. Any questions on that one? Does that make sense? Okay. Now, for the next one, because it's addition, you can simply add your whole numbers and add your fraction parts, and that will work. So we can do that with this one. Or what I always like to encourage my students who maybe struggle a little bit with when do I do this, when do I do that, I always like to say if you have mixed fractions, you can just use improper. It's the same thing. So if you did it by saying, well, 2 plus 3/4 is what 2 and 3/4 is, plus a half, then I can bring down my whole number, and I could simply add my other parts. Common denominator would be 4, which would be 5/4, which is equal to 1 1/4. Add that to the whole number that you brought down, and your final answer will be 3 1/4. That's your final answer. Alternatively, instead of doing that whole rigmarole, I could say, well, let's just start with 2 3/4 as an improper fraction. So if I think about what 2 3/4 looks like, highlight it. There's 1, there's 2, and 3/4. So how many quarters, raise your hand real quick, how many quarters does 2 3/4 have altogether? Anybody? How many? There's 11 quarters. There's 1 quarter, 2 quarters, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 quarters, or 11 quarters of pizza, or 11 quarters of chocolate bar, whatever. So 2 and 3 quarters is 11 quarters as an improper fraction. You can either draw it to think about it, you can just think about it contextually, or your teacher in grade 7 said multiply your denominator by your whole number, so 4 times 2 is 8. Add your numerator to get 11. Keep that as your new numerator, and simply keep your denominator as is. That's how you change the mixed fraction to improper. So if I do this every time, this is a lot easier because this process is now the same for subtraction or addition. It doesn't matter. Find your equivalent or your common denominator, which in this case is going to be 4. So multiply this by 2 and multiply this by 2 to get 2. Add your numerators. Keep your denominator. Your final answer will be 13 quarters. But since teachers don't like it when you answer as an improper fraction, we convert that to a mixed. How many 4s are there in 13? There's 3. That makes 12. And since we have 13, that's 1 extra quarter. So your final answer would be 3 and 1 quarter. And your final question is subtraction of mixed fractions. And again, in grade 7, your teacher probably taught you how to borrow. But if you use this new method where don't ever use mixed fractions for addition and subtraction, in my opinion, it makes it much easier. So we already know that 2 and 3 quarters is 11 quarters. Takeaway. If I was to draw 1 and 5, 6, it would look like this. 1, 2, 3, 4, 5. And 5, 6. 1, 2, 3, 4, 5. Take my highlighter. There's 1 and 5, 6, just like that. How many sixths does 1 and 5, 6 have? How many sixths are there here in this picture? Don't all shout at me at once. I can't hear it when you're all excited. Tegan? There's 11 sixths, isn't there? There's 6 here, 7, 8, 9, 10, 11. So 11 sixths. The easier way to get that answer without having to think about context. 6 times 1 is 6, plus 5 is 11, over your original denominator of 6. Now here's a tricky question. What is the first multiple 4 and 6 share? It is 12. If you use 24, is it wrong? No, because 24 is a common denominator. It's a common multiple that 4 and 6 share. But if you're smart and you made your multiplications, your multiplication comparisons, you realize that 12 was the first one. If you use 12, it makes it easier because you keep your numbers reasonably small and in lowest terms. So you get 33 twelfths as an equivalent fraction. 6 times 2 is 12. 11 times 2 is 22. Once you get there, keep your denominator of 12 and subtract your numerators. Your final answer is 11 twelfths.